Boom! What's up, everyone? Welcome to Simulation. I'm your host, Sonication. Super excited to be talking about influencing the global brain. We have Sterling Cooley joining us on the show. Hello, brother.
Hey, how's it going, man? Good to see you.
Super excited for this episode. It's finally happening.
Totally.
Yeah, we greatly appreciate all of the love that you've been passing along to Simulation. So many of our friends have been on the show.
Yeah.
You've been sharing those shows. Now it's time to feature you.
It's exciting.
So pumped. For those that don't know Sterling's background, Sterling Cooley is a thought leader and pioneer in the use of ultrasound to modulate neural activity in the human brain and nervous system. He is a contributor to the Transformative Technology quarterly report for Vagus Nerve Sector. He also runs the fastest growing community on vagus nerve stimulation and repair. His other interests are in bringing a neuroscientific understanding to how the modern corporation operates to increase well-being, productivity, and human thriving within the organization. And you can find the links in the bio below to sterlingcooley.com, as well as the Facebook group. That's facebook.com/groups/the Vagus Nerve. So do check that out. Join that group. Awesome. Sterling, let's start things off with one of our favorite questions to ask our guests. What are your thoughts on the direction of our world?
That's a good question. I think a lot of people are a little bit more pessimistic than they need to be. I think we have to have a framing of optimism, because that's the only way we can find really good solutions. And we have to be curious enough to be receptive for the answers. So I think while it might seem really chaotic, the flow of history is actually probably going in a good direction.
What are the most pressing things that you think we need to embody in order to make sure we're not just another collapsed civilization?
Well, I think we need to realize that the whole planet is together. We're all in this together. Like, our fate is the same as everybody else on this planet. And I'm really, maybe I'm jumping the gun, but I think we really need to get to Mars, like, as fast as possible. Like, that should be one of our number one priorities, honestly. Because we need that kind of redundancy. We need that kind of decentralized system. We're very centralized. We have blockchain, but humanity is on one big rock at this point in time, and that's a pretty dangerous place to be. So.
Yeah. So adding a couple celestial bodies decreases the existential risk.
Exactly.
Okay.
Exactly.
Okay. Cool.
Yeah.
Cool. Yeah. It's a very cosmic. Yeah. We got to take care of this house as well. Make sure this house doesn't burn down. Like you said, it's so interconnected with the 8 billion of us and all the species.
Exactly.
Let's get into the journey. You're born in Oregon. Mm-hmm. How did you pick up your interests in neuroscience, consciousness, this field as you're growing up?
Well, I was a bit of a loner growing up. I was hugely into just being on the internet, not really getting into the gossip at school or anything like that. And I just was like a sponge. So I think I happened upon some show called Coast to Coast AM with like George Norrie, which was like an old like AM, FM, or an AM radio show. And they had the weirdest guests on, and I would sit at home in middle school and just listen to these people. And then I heard one person, Stuart Hamroff, who's a MD in Arizona, and he was talking about microtubules and consciousness and this incredible stuff. And I was like, this is amazing. There's just something about it just struck a nerve for me. And I couldn't really do anything because I was like 13, 14 at the time, but I kind of set it aside in my back of my brain. And then when I was about 23, I was like, what's Stuart Hamroff up to? And so I Googled, and I realized he was doing some incredible neuromodulation using ultrasound. And I was like, this is it. Like, I knew it back then when he was talking about microtubules, even though I didn't know what they were really. And then I read about the new ultrasound stuff, and I was like, this is definitely going to be the future.
And what are microtubules?
Yeah, microtubules are basically the cytoskeletal scaffolding in all of your cells. So what makes your cells not just amorphous blobs and able to hold a shape that's like long neurons, it's entirely dependent mostly on microtubules, which extend out like these big straws. And Stuart Hamroff found out that these tubulin that make it up are like these self-assembling particles, or they're proteins. And they may be able to process information individually. So people think of a neuron as like the central node of an information processing system. He discovered that it might actually be like the strands inside of it, the microtubules, that can calculate really complex information. So
microtubules act as scaffolding within cells to make them have a shape.
yeah.
Okay.
Yeah.
And to be able to hold all of the interior complexity of the cell. Interesting. And
Yeah.
they're made of proteins. The scaffolding, the microtubules are protein. They're made of proteins.
Yeah, so they're tubulin that like arrange by themselves, and they can extend or shrink. And in your cortex, you have these big pyramidal cells, which are like tons of microtubules that are steady for most of your life, and they kind of act as like information processing centers. And so it's a really new theory. It's been around for about 30 years now, but it's a really cool theory.
And then the similar with cells for the rest of our body, as our neuronal cells have microtubules as well.
Yeah, every cell in your body has microtubules.
Okay.
Some of them are more seemingly specialized in the brain.
Oh yeah.
In terms of how they're arranged. Yeah.
Yeah. Okay, and then so then at 23, when you were like, okay, neuromodulation, I'm really interested in this. Then take us from that part of the journey.
Yeah. So I essentially just dove in head first, not really knowing what I was getting myself into. And I was like, okay, this is it. And I started my first business at 18. So I was like, there's got to be some opportunity in here. And it turns out that there was. Essentially, there's a huge gap in terms of people who are able to bring really smart ultrasound physicists to the space of clinical applications to actually provide the hardware to research this work. So there's a big gap that I was able to just fill, really because of luck. Really was just a good timing in the market, and I saw an opportunity. And so I was able to essentially provide some of the equipment, the ultrasound, to fill the gap in clinical neuroscience. So it put me right in the fray in working with Jay Sanguinetti, Stuart Hamroff, Jamie Tyler, who ran Think for a while. So it just put me in this central location to work with these amazing people in neuroscience and engineering. And so it really took off from there. Within 12 months, I was already in China, manufacturing ultrasound. So it was a pretty wild, fast meteoric rise.
And that was with Berkeley Ultrasound.
That was with Berkeley Ultrasound.
Okay,
yeah.
okay. And prior to that, you were doing ID Tech camps. You were lead instructing some C++ programming. Okay. And after teaching programming and game design courses, the Berkeley Ultrasound, you said there was, this is called, the brain stimulation platform is called Lift Up, Low Intensity Focused Ultrasound Pulsing Stimulator.
Right, pulsations, yeah.
Pulsation,
yeah.
Okay.
Yeah.
Okay, and so so teach us about that, and then what that was like, because this is reversing depression, helping treating Alzheimer's and dementia, all different types of variable illness and disorders of the brain, including eradicating tremors caused by Parkinson's. So many things can potentially be healed with this. Yeah, so walk us through what this was like. This was 2013 was the start of this.
Yeah,
right?
so at end of 2013 and really got started in 2014. And by 2015, I was in China manufacturing a perfect culmination of all the requests from the clinical applications that were coming in they're like, well, we want to treat depression, we want to treat PTSD, Alzheimer's, dementia. And so I had to take their specifications and see what we could engineer in terms of something that was small, portable, affordable, easy to program. There's a lot of pain points in this industry. It's very complicated stuff. And so I wanted to try and make it simple enough so that any grad student could kind of dive in and start getting into the work. And so culminating in my I think it was about 5 months in China, in Shenzhen, through the help of shout out to Ryan Bethencourt and SOS Ventures and Sean O'Sullivan for helping me get in there. And so we manufactured this really slick, portable, small research device that could allow you to program ultrasound, stimulate the brain, and do all kinds of amazing stuff. And so from that, it really opened up this door to see what really could be possible here with ultrasound. And so through that, I started realizing that it's not just the brain that you can stimulate, but neurons run through your entire body. And so I've recently come across the fact that you can actually stimulate other parts of your cranial nerves, trigeminal nerves, and other parts of your body with ultrasound really effectively. Yeah.
And we have some assets to start showing here too that I think can help us. Yeah. Okay, so what you were manufacturing in 2015 was this portion here.
Yeah,
Okay.
so that's a transducer. That's where the ultrasound comes out. So I was working on those and the electronics that drive it.
Yeah.
Yeah.
And making it easily programmable.
Correct.
Okay,
Yeah.
to change things like the hertz, the frequency, these things.
Yeah, the intensity, the pulse rate, the frequencies.
Okay.
In some cases, you can change the focal distance, so you can, steer the ultrasound beam. This is going into the deep brain. Is one of the applications I'm currently looking at right now for pretty similar to what Jay Sanguinetti is doing in terms of mindfulness, meditation, that kind of stuff. So that's a current application.
And then, so when you guys were figuring out to manufacture this, was it kind of like we're gonna create this for like clinical use? Was it for personal use?
Clinical use.
Yeah, clinical use. Yeah. And then to eradicate some of the ailments that we have with our health.
Yeah.
That was kind of the thing.
Yeah.
Okay. And then
it all started originally in the temporal window, so right here, so really above your temple, right above your eyes, on your forehead kind of. And so that was to treat depression that starts in the prefrontal cortex. There's this weird desynchronization that happens. So your two lobes, your left and your right, will start pulsing at different frequencies. And that's a big indicator of depression, actually. So the original usage of ultrasound was to try and regulate the both hemispheres to synchronize at the same time in the alpha band. And that was some work kind of pioneered by John Allen, Dr. John Allen in Arizona as well. So he's like the mentor to Jay Sanguinetti. And so that's really where it started with Stuart Hamroff and all those people.
And so then the distribution of this through Berkeley Ultrasound ended up getting into the hands of you guys ended up manufacturing, getting into clinics?
Yeah. So mostly in Tucson and, kind of some clinics around the world.
Cool.
In small limited applications, because there's a lot of issues with the FDA, and it's a very advanced. It's on the very edge of research. So there's a lot of work that needs to be done still.
To make sure that we're not harming people by accident, that the technology is exactly what we say it's going to be doing, all that kind of stuff, that it's tested properly. So then that was 5 years of doing that. Okay. And then we have so
that's another example of what that would look like.
Damn, this looks like it's much more like 2030 or something.
This looks like a satellite from space going into your brain. This is just a mock representation of what that might look like with ultrasound. So pretty much the primary applications right now that people are looking at is really taking a single transducer and putting it deep into your brain to try and affect like the limbic structures, the basal ganglia. Some of that work is around your ego, your sense of self, rumination, which are things that really contribute to depression. Like your sense of, are you good? Are you good enough? So part of this is to try and turn that down a little bit, to try and make somebody's lived experience a little bit more comfortable. So that's kind of the current application that a lot of people are looking at.
Okay.
And so this is just this is kind of what it looks like when the ultrasound goes into the skull and into the brain. So you can see there's kind of a small targeting area. It's called Sonication. And so this is some pioneering work on how to stimulate the brain using ultrasound.
Damn, so it's a lot of that, the rumination on if I'm good enough, that's usually what gets, you said it's the left and right temporal lobes are not in synchrony, and that's
in some cases, that's seemingly what John Allen discovered. And so if we look at this one, it's a little bit cut off on the edges, but some of the work.
We'll bring it in right now.
Oh, okay, cool. So some of the work, the original work was hitting the prefrontal cortex with ultrasound to try and regulate the left and right part of the prefrontal cortex. But now the search is actually deeper into the limbic system. So it's essentially looking at, regulating people who don't feel safe or feeling unloved or feeling bad emotions, these kinds of things. So really regulating like stress and fight or flight response. So people can feel kind of, I guess, better in their body, to feel more centered and more grounded. And so this is where a lot of the research is right now.
Okay, okay. Yeah, because going in, deeper is harder to the limbic than it is closer to the surface level of of the cortex.
Yeah, exactly.
Okay.
Exactly.
Okay. All right, and then the next asset shows some of those limbic infrastructures.
Yeah. So this is more of a cross section. So the limbic system is really represented in this very centrally located part of your brain. It's like hippocampus. This is like where memory, emotion, fear, stress, a lot of this stuff resides. The sense of the self even resides in here as well. And so it's a really important area to stimulate. But whereas most of my colleagues are attempting to enter into the brain through the very top down and trying to penetrate through the skull and a lot of matter, there's actually a lot of work showing that there's another way into the limbic system. And it's not through the skull, it's actually through the cranial nerves that enter in from underneath your head.
Yes.
And so that's really where I've actually started shifting a lot of my attention, is to how do we get into, this is like considered the back door of the brain. That's very underexplored, but there's huge potential in that area.
Yeah, so there's 12 total cranial nerves?
Yeah.
12 total cranial nerves, and the vagus nerve is the 10th.
Yeah, so the vagus nerve is the 10th cranial nerve, and
okay, let's show the next slide too with this. Yeah, keep going.
Yeah. So so basically this is a shot from underneath the brain. So looking up, and you can see there's a lot of these nerves. So essentially the 10th cranial nerve right here, X, is the vagus nerve. So it regulates heart, lungs, your stomach, your throat. So how you speak, tons of stuff, even reproduction, hormones, your level of stress, safety. There's a lot of stuff is tied up in that one nerve branch. So it's pretty much a direct input directly into your brain. And the networks are very interconnected. So it's a direct access to your limbic system.
And these all run up the spinal cord?
So these are separate from the spinal cord. So
Some run up the spinal cord, right?
Yeah, so there's the parasympathetic nervous system, which is your sense of safety. Generally speaking, it's the ventral vagal. That runs outside of the spine, of the spinal column. And then the sympathetic nervous chain, which is the fight or flight chain, which is where you feel scared and fear, actually runs through the spinal branch.
Because then that enables you to flight if you need to with the motor function.
And it's the most important thing to be protected too. So if you think of predators in the wild slashing at you, not to give you too much of a graphic image, but if your instinct is to survive, you would want your most important functions of running away and finding food to be as protected as possible. So they're in the spine, they're very protected.
And there's like some of these cranial nerves are known as just sympathetic nervous system?
No. So the sympathetic is kind of the chain that connects to a lot of your organs that kick you into high gear. So making your heart beat a lot faster, to release adrenaline, to make your eyes widen so you can like really see things.
But the cranial nerves don't separate into sympathetic and parasympathetic, do they? No.
It's more of a classification of what they do, Yeah.
And so then the vagus nerve is this wandering nerve within the central. There's like, there's two of them?
There's a left and a right.
Left and a right.
And then there's a dorsal and then a ventral.
Okay.
So ventral means it comes out of the front, and then dorsal is out of the back part of your brainstem. And there's a left and a right side, and it's really a wandering nerve. That's what the word means. Vagus is Latin for wanderer.
Wanderer. And that's how it connects to the
so this is it wanders all the way through your body, and so there's so many graphics I could show you, but it really does connect to so many of these other parts of your body.
Yeah, let's go to that next one, which is the 10th.
Yeah, exactly. So here's kind of a overall view of the 10th cranial nerve. So again, this is where it exits from your brainstem, and it runs down here to your throat, so it controls your ability to speak, to swallow as well. It influences hearing. It influences your lungs, brachiation, how much oxygen you breathe, your heart, your liver, your stomach, your spleen, your pancreas. Controls blood glucose levels, insulin release, digestion. There's a whole bunch of stuff that's very intertwined with this vagus nerve. So, and basically the vagus nerve is two main things. So there's efferent cells or efferent lines that go down, and afferent, which go up. So efferent is 20% of the nerve fibers, and that means that your brain sends signals down about 20% of the time, but your vagus nerve reports 80% of the time up into your brain. And so this tells you if you're hungry, if you're full, if you're tired, if you're thirsty, if you're horny, if you're any number of things that are connected to this. If you feel sick, if you feel like you gotta puke, all that stuff is reported on your vagus nerve.
Damn.
Yeah. So it's a ridiculously important part of your function. And so we know a lot about it because they used to do a lot of surgery on this nerve to actually to cut it for certain kinds of disorders. So like if you got like ulcers a lot, they would actually snip your vagus nerve right down here. That's like a very common thing. But what they found is that in the populations in Scandinavia that actually had this surgical procedure done to snip their vagus nerve from the stomach down, that they had a way fewer incidences of Parkinson's disease. And some people are like, well, what's going on with that? And they found out that most likely Parkinson's starts in your stomach and then it travels up your vagus nerve into your brain.
Whoa.
Yeah. So it's really important. It's a really important nerve. So you got to really take care of it.
So much of what's going on in our bodies, organ systems are actually being communicated up. So our brain only becomes aware of them because the organs are communicating it through the vagus nerve up to the brain.
Exactly.
And then we make our next decision based on that feeling that we're getting.
Yeah. So it's super important and one of the other things was in terms of, so there can be like surgical accidents or for whatever reason a car accident where it gets severed a little bit closer to the head. And this is one of the interesting things is that they found that people who had a severed vagus nerve higher up had a way higher incidence of schizophrenia. So it means that the brain is essentially waiting for input from the vagus nerve. It's not getting anything and it's hallucinating inputs. And that's possibly a reason why, people can hallucinate when they have, schizophrenia.
Damn.
Some dysfunction of the vagus nerve.
I'm excited to talk about stimulating this as well.
Totally.
Let's do the factors affecting breathing, which is the next one.
Yeah. So for a lot of people watching, you might be like, "How do I stimulate my vagus nerve?" It's actually really pretty easy. Breathing with your diaphragm. So you can take deep breaths like. That's kind of a starter way to do it. And then another way is to breathe in and hold. And this is called a Valsalva maneuver, and you actually squeeze in your chest, and you kind of do this squeezing method right here in your chest cavity, here with your diaphragm, and then you slow exhale. And so what that's actually doing is it's in a way pinching the part of your vagus nerve down here that runs through your diaphragm that holds your lungs in and out. So that's like a very easy way to stimulate your vagus nerve. I really recommend that for most people who just want to see like what it's like to get started.
Do you think it has something to do with the amount of oxygen that we take in that stimulates our body through a much deeper breath, and then we hold it in, and then we're giving it more time to absorb rather than the immediate shallow breaths?
Definitely. The oxygenation is really key. It's a very interconnected system. So more breathing expands your bronchi in your lungs, and your vagus nerve runs through that, so it's getting stimulated. It releases more acetylcholine, which helps downregulate inflammation, downregulate stress response to things. So overall, it's a really good thing. But yes, so oxygenation is really a good part of it. And I think people just need to breathe more. People if you look at them, they're just like they're hypertensive, not breathing, and that causes all kinds of issues. Yeah.
The deep connection to breath. Yeah. Okay. All right.
So in terms of other ways to stimulate your vagus nerve, where it gets more invasive, where it's not very natural.
This is external though. This is still
outside. No, this is actually under the skin.
This is under the skin?
Yeah, so this
you can do this outside of the skin too, right?
You can in a way, yeah.
Okay.
Yeah, this was FDA approved for treating epilepsy.
Okay, yeah.
So for people who really, really needed help, they found that stimulating the vagus nerve during an epileptic fit actually reduced the severity of epilepsy, of a seizure.
Okay. Wow.
Yeah, so it's very, this network goes all the way up into your brain. So so essentially there are, I don't know, probably about 40 to 50,000 people walking around with this implanted in their body.
Already.
Yeah.
Damn. And there's like how many millions of people have epilepsy around the world? Something like that?
I think it's like 120,000 that could potentially have this.
Oh,
yeah.
Okay. It's not that, okay.
It's not, that would be, I've looked at the market size for this, and it's closer to about 120,000, maybe a little bit closer to 200,000 worldwide.
Okay.
Something like that. So it's a relatively small market in terms of people who are able to have this implanted. But I mean, this is kind of a first step in terms of I think transhumanism, this is directly modifying a very important part of your neurology.
So you're putting in a pulse generator with a lithium ion battery, something like that, and then that connects via an electrode to wraps around the vagus nerve. And
it's called a cuff. It wraps around it like this, like fingers. Yeah.
And then it only activates when, is it like a remote activation when I'm having an epileptic episode? I stimulate.
You have a watch on that has a magnet, and you run it across. Wow. It's under your skin, and so you can run it across. So if you feel like you're having it, then you can activate it.
Wow, that's
and it'll
so
go for about a
transhuman.
minute. Yeah. So you can on demand stimulate your vagus nerve. Wow. And so the odd thing about this was that even though some people, it worked really, really well. So it's very, very good procedure for the most part. But people who they didn't have any reduction in epilepsy noticed that their major depressive disorder actually went away after about 6 weeks of having this installed. So that got people to wonder, could the vagus nerve be related to depression also?
Yeah.
And so through a lot of research, they did clinical trials, and they found that for people who don't have epilepsy but have major depressive disorder, like treatment-resistant depression, essentially, that it actually helps treat depression very well. So the FDA approved it for that as well now. So this can treat depression and epilepsy and eating disorders. Now they're doing this for, because the vagus nerve regulates your sense of satiation, hunger. It's all in there. There's a lot of important stuff in there.
I'm curious as to this being an appendage, like a physical appendage that we bring from outside, that to solve kind of what could be viewed as a second order symptom of what is a first principled disconnection from nature, something. So yeah.
I get what you're saying.
You get what I'm saying. Yeah. So what are your thoughts about that?
I mean, I've definitely, this is a lifelong question. When you deal with technology that can help people, you say, well, should we even be in a society that needs to create technology to help these problems that could likely be related to lifestyle and the environment and people being stuck inside of cubicles all the time? And I think these things are definitely good questions to ask. But the reality is, this is easy. This is something that we can have implanted in you pretty darn fast. And then from this creates the change, the room for change. So people who have these kinds of things, they notice they're going out in nature more often. This is life-changing kind of stuff.
Okay, so it's harder to repattern someone's behaviors towards source or spirit than it is to potentially add something in that makes them more transhuman, that can maybe create that deeper interconnected connection.
Yeah.
Damn.
It's artificial is the key word for the future. Artificial.
It does seem to be that way.
Yes.
Absolutely.
Hey, whatever it takes.
Yeah, I mean, the thing is, when it comes to epilepsy, the reason that was approved is because epilepsy is not something that you want to live with. It sucks.
Yeah.
It's life-altering.
Yeah, and it's not just as easy as saying go get more trees and sunlight and ocean, for your epilepsy, correct.
I can't say, you have epilepsy, go eat more dirt, get more bacteria,
It's very complicated, totally.
Yeah.
The way the physiology interacts with the environment is very complicated.
Yeah.
It is crazy that it's just such a crazy thing that the first order disconnection from source and spirit is now augmented by technology to maybe get us closer to that and towards the unity. It's a very interesting dance that we're playing with the tech. Very interesting dance.
It is fascinating.
Well, we fail to do it ourselves.
Yeah.
Period.
Yeah.
And if we don't get it right within, if we don't take those steps, they're going to do it for us. Don't ask me who they are, but they're working on it.
Yeah, that's a good way to put it. If we fail biologically to recognize the interconnectedness ourselves, then the civilization will collapse unless something comes in to save the day. And maybe
this is what's coming in to save the day.
Yeah.
What Sterling's working on, and everybody else that we have on this show are doing just that. They hold the key to.
Yeah, this is a key technology, and I do want to say, like, you know, I have a friend who works at Stanford he works with this technology, and he'll jump down my throat if I don't say, like, you know, epilepsy is not, I don't think, curable by getting in nature or anything like that.
Yeah,
necessarily. There's
totally.
some genetic things that are happening.
When you have that tumor pressing on your amygdala and you're going to kill your wife and your kids, there's no way.
There's some times where you know. Really technological intervention is very helpful. And there's not really, like, you know, any amount of meditation that you can do to make epilepsy
any amount
go
of
away
meditation, and also and the argument of nature is that, oh well, then it's that person's time that's part of the consciousness experiences is to go through that process of suffering and committing that act and going through that, versus the argument of the technologists is that we can eradicate that suffering. We don't need that suffering to happen. We can prevent it. That person can live a healthy life, and then that's kind of going against the natural of what's natural.
Exactly.
So it's a very interesting, complicated conversation that we've been having the last couple weeks, especially about like the role of indigenous wisdom and the role of technology.
It's true. It's hard to say. I mean, you know, I think we'll get into this later, but we're part of this big superorganism, and we're all trying to find an optimal path forward. So some people will try an optimal path that doesn't end up working, and some people will try the path that does work. And so we're all, like I said, we're all in this together. This is all a big global superorganism system, and this is part of it. This is absolutely part of it. So yeah,
let's hit the 10th asset. Let's do it. Let's go on.
Yeah.
Okay.
So in terms of, you know, some other areas where this electrical stimulation of the vagus nerve is working is really regulating inflammation in the body and regulating very like metabolism style processes. So when you stimulate the vagus nerve, it actually interrupts the process of your macrophages in your spleen. Not to get too complicated, but it stops them from releasing inflammatory cytokines like tumor necrosis factor alpha and interleukin 6, which are, you know, we know that those actually help destroy, not help, but actually destroy healthy tissue if you have too much of it. So people who are overstressed have an overabundance in this inflammatory cytokine. And so vagus nerve stimulation releases more acetylcholine, ACH, which actually changes the DNA expression in the macrophages to be, it's basically like meditation is one of the things that helps, but vagus nerve stimulation also does very similar stuff. And so that's actually being clinically explored right now. So how can we reduce inflammation in people? Because it's one thing to get your mind on top of the stress, but it's another thing is if you've been stressed for the last 3 years, your body is just flooded with cytokines. You got to take care of that stuff too. And so, you know, it's like you don't have much time. If you've been stressed out for 3 years and your body's been pumping out inflammation because it thinks that there's like an intruder in your body, which is really just more of a psychological intruder, which is still real in that sense, then you have to deal with that too. And it's kind of like immediately, as fast as possible, you have to deal with that. So.
Wow. So actually, decreasing the inflammation within the body through vagus nerve stimulation as well. The biohacking.
Yeah, and so in terms of other ways to biohack, if we look at the next slide, we'll see that you know, human connection is a really great way to actually stimulate the vagus nerve. Like we are social creatures. The vagus nerve is what is feeling in our heart, in our body, in our gut. that gut feeling about a person. That's all your vagus nerve telling your brain how it feels about another person or about a situation. It's called neuroception. So it's you have perception through your eyes and ears and taste and touch, but your body also has a perception as well. So yeah, when you hug somebody and it feels really good, that's essentially like this vagus nerve telling you like, okay, I feel safe. You should feel safe now. And your brain going, okay, I feel safe. So it's it works together. They all work together. Yeah.
So the vagus nerve going and connecting so many of these key organs within us, and then the body to body, like, so that's kind of one of the indications we get within our mind that we get these warm and fuzzies, that this is a trust.
Yeah, exactly.
Interesting.
So trust is a big part of it.
And this has a lot to do with oxytocin as well?
Absolutely. Yeah,
Okay.
oxytocin release. Totally.
Okay.
And reduction in like adrenaline, reduction in cortisol.
Yeah.
Those things, because those make you feel like you're unsafe.
Unsafe, yeah. Okay. All right. And then.
And so I'll kind of go over this kind of briefly, which is that there's the three main systems that your vagus system can occupy in terms of like energy. Is the top one is the most desirable one, called ventral vagal, which is where you feel safe, connected, you feel like you're part of something bigger. That's really our social engagement system. That's what you want to be activated. But if you are not feeling able to engage or connect with people, or if you feel afraid or threatened for whatever reason, then your body will activate this sympathetic nervous system. And that's where, that's your spinal column of your sympathetic nervous chain. And then it'll start stimulating your organs to release adrenaline and start feeling freaked out. Maybe you should run. Maybe you should, fight. Maybe you need to fight somebody. And this starts influencing your brain as well, because your brain is part of that system. And so it'll start imagining like scenarios where you're fighting or running away. And so this is a chain that starts, it's a chain reaction. It's a loop. So your body feels unsafe. Your brain imagines what you would do in that situation. And your brain can't tell the difference between imagined or real in a lot of cases. If I visualize something, it can almost feel real in my body. And so then your body reacts, your brain reacts. So people can get stuck in this sympathetic system. And that's where people are like under this constant stress. And once you get enough stress and you feel like there's no button or thing you can do to press, or you can't escape it, your body will essentially get into a place where it's passive, it's immobilized. So that's essentially what happens when you go into dorsal and you just lay down and you say, it's no use, it's hopeless. It's like total down in the depth of depression.
Whoa.
Because your body is just like, I can't fight my way out of this. I can't connect with people, so I'm going to go and shut down. I'm going to maintain as many resources as I can and go into hibernation.
Whoa! And then what are the and then the vagus nerve is related to all three of these. So then these three. So then it kind of does it kind of like pick and choose between the three: mobilization, and signaling system. Like, does it kind of like? Yeah. Okay.
Yeah. So the anatomist that discovered the vagus nerve, his name was Galen. He was a Roman guy. He was a Roman dude taking apart warriors or whatever who were fighting. What are they? The centurions. And he discovered this nerve, and he classified these chains as the one thing, but they're not really the one thing. They're part of the vagus nerve system. But once they looked at it closer, they're actually kind of like a little bit separate. So there's dorsal vagal is separate from ventral vagal, but they are sort of in the same kind of. They connect in the same area of the brain.
Okay.
And how did he acquire the cadavers?
Well, he was dissecting pigs, and he was in Rome at the Colosseum, so he was dissecting dead fighters, actually.
Fighters.
Yeah.
Humans.
Fighters. Yeah, humans.
Okay.
Yeah. And it was funny. I was reading this last night. Not funny, but some of them would have slash marks right on their neck, so it would have severed their vagus nerve, and they had weird symptoms that developed from that. And so he was able to kind of detect that these nerves are really important for feeling relaxed. So these people were like constantly on edge because they had some damage there. So that was.
I know where we can get some specimens if you want to, have our own. The city is
No worries, no worries.
It's okay.
But we understand a lot more about this than he did. That was about 200 AD.
Exactly. That's why I'm saying now is a good time to experiment once again with human beings.
It's also it's nuts thinking about the what we were doing to discover the initial parts of the internal operating systems in the past, and like what technology we have now to discover the internal parts of the operating system that we live in.
Yeah.
This I feel like we ebb and flow between the different states here so frequently.
Right.
Yeah.
So your body basically is in one of these at either time for the most part, but there is one where, so if you, for instance, are activating dorsal and ventral, you can have this really intense feeling of safety with another person. That's very visceral.
Yeah.
And so you can actually activate ventral and dorsal at the same time.
Yeah.
And that's a really coveted, coveted thing. And then you can also do...
that's maybe when you're in love or something.
That's when you're in like deep mad love with somebody.
Okay.
Yeah. That's like the pinnacle of what your system can provide, pretty much.
Yeah.
Yeah.
Okay,
Yeah.
cool. And then let's move on to the polyvagal theory.
Right.
Okay.
And so this is the recognition that you essentially climb a ladder of the vagus nerve, essentially, in terms of you are a dorsal vagal if you just can't cope with anything, and then you can move your way up to sympathetic, where you're like, I'm mobilized, I'm ready to fight, maybe run. And then it takes that to get to this place of feeling connected to the bigger picture, part of the world. And these are kind of like growing out of our evolutionary history as well. So there's the reptilian brain, then that's like fighting and fighting. And then there's the cortex, which is more of the ventral vagal. The ventral vagus, the vagus that activates when you're in love, is a very new structure. It's more of a mammalian structure rather than like an old antiquated reptilian thing.
So then what is the vagus nerve doing in the three examples here when it's in the state of feeling connected to the greater world?
Right.
This is what we were discussing the last one as well, the interconnectedness between those two slides.
Yeah, exactly. So ventral vagal essentially does a lot of stuff physiologically. And so we're going to do a little bit of a demo to show you how to actually determine where you are.
Yeah, let's do that.
So in the next slide, we'll look at this. So you can essentially determine how your vagus nerve is operating based on how your heart rate is and how much variability you have in your heart rate.
Okay.
So I have this tool that I brought. It's a demo.
Okay, cool.
This is from a company called Elite HRV. And so it's a little finger sensor that you put your finger into like this by Core Sense, and there's an app. So I'll show this here.
Okay, yeah, and just hold it steady so Ron can
Yeah, so I'll hold this steady. So to measure your heart rate variability, aka your vagus nerve health, you want to breathe in when the circle gets bigger, and then breathe out when it gets smaller.
Do we need to click start too?
No, it's
auto sensing it.
It's auto sensing it now.
Okay.
And so basically my variability score is about 55, 57.
Okay.
And that's a little bit low, but I'd definitely say, because I'm on a live stream, I'm probably a little bit more, in mobilization.
With a heart rate of 100 and a variability of about 55. Okay.
Yeah, pretty much, which is pretty high, I'd say. I'm definitely ready for.
But
the
it just
studio
went down to
environment.
79. It seems like it's kind of jumping quite a bit. Yeah.
Yeah, exactly. So if I'm talking and moving around, then it definitely affects it. So.
Okay. And what do you learn from seeing the measuring heart rate variability related to the vagus nerve?
Yeah. So if you're in a really stressed out state, your vagus nerve, your ventral vagus nerve, is not activating as much as it should. And so your vagus nerve connects to the bottom side of your heart, and it's called the vagal brake. So it puts a brake on your heartbeat. So essentially, if your ventral vagus nerve is working, then it'll send a short burst to your heart to slow your heart rate down. And then the ventral vagus nerve will sap activity and not activate as much, and then your heart rate will increase again. So in people who are hypertensive, what you're gonna see is that there's no variability at all, which means that their ventral vagal system, their social engagement system, is just not working at all. It's just not activating. So it means that they're probably in sympathetic nervous chain activation, meaning that they're in fight or flight. And so that's what you would see. So you'd see like pretty much a flat line across here, and this variability number might be down like to 13 or 20 or something for like really hypertensive people.
And that means you're in a state of like your sympathetic nervous system, your fight or flight, your panic. When your heart rate variability is just barely varied at all. And like super relaxed is super varied.
Yes, yeah. So if you're relaxed, your heartbeat should sound like a jazz song. So it should be like dum 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 bum 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 bum. So it goes faster and slower with your breathing. So when you breathe in, your heart rate increases, and when you breathe out, that's when your ventral vagus nerve slows your heart rate down. So it's slower, and then the chain continues like that. And so that's a good sign. You want to have that. So you can do it for yourself at home. If you can measure your heartbeat, you can take your fingers and put it on your pulse on your wrist.
Or even I was just feeling it right here even. Just
in your throat here. Or right here, this spot right here, this soft spot. Your heart's just below that. And so if you breathe in, your heart rate will increase, and then it should slow down. It might even skip a beat if you're really relaxed, actually. So that's
great.
That's heart rate variability.
It's so important to be able to feel our heartbeat.
And so in terms of, that's kind of what that looks like. And so if we go to the next slide, the company Elite HRV released some data on 24,764 users of this same technology. And what you'll notice is that it's a bell curve distribution. And the average is about pretty much where I was. I'm about 55 during this interview. Normally I'm about 67, 70, if I'm just sitting or whatever. And so what I've noticed from this is that people influence each other. So we have a social engagement system. So I'm pinging you, you're pinging me. We're influencing each other in terms of stress level. Because we look to our nearest neighbor to see, is there something we should be afraid of? It's kind of like the global brain, like mass psychology, the mob mentality. So we're all pinging each other. So what this shows for me, what I read out of this, is that we're all kind of globally influencing each other's heart rate variability. It would be weird if we saw like a dumbbell kind of distribution where it was like one population down here and one population down here. You might see that if you compared like somewhere in a war-torn country versus like the affluent West. You might see this big distribution. But it's this kind of localized area for heart rate variability. And so what that says to me is that local populations influence their own level of stress, either up or down. And so that's kind of this idea that, we think of our brain as the node in the network, but our vagus nerve is kind of a social network node that remembers people in some way. It has a storage system of like, these are triggers that make me feel upset or scared, or these are things that make me feel safe. And so these are kind of things that are relegated to the vagus nerve. So this is what this shows me.
And like you're giving this perspective of of being able to think about things like a global brain, and the way that we are engaging with each other right now, when we can like butterfly effect our like states of happiness or stress onto each other, and how that affects our heart rate variability. You can see it like on a global scale. Areas that are maybe more relaxed are at higher heart rate variabilities, and more stressed on lower heart rate variabilities. So if you can influence other people around you towards relaxed states, joyful states, etc., then that's these are the big things we can do with spreading memes of that style as well.
Exactly.
Yeah, using neurotech tools to get us further towards the relaxed states.
Yeah. And so this is kind of like people talk about raising consciousness, like the upward spiral. This is kind of an indication that, I guess maybe if we measured this 100 years ago, we didn't have the technology to do that, but it probably would have been lower. Probably would have been a lower HRV. And I don't know for sure, but I think in the future as people start kind of engaging more socially, connecting, feeling safer, feeling more optimistic, more creative, more curious, that the HRV of the globe will actually start inching up. And so that'll be kind of an indicator of global health. Like the mental health of the entire planet could be represented with this one number, potentially.
Yeah. Whoa.
Yeah.
Do you think the mental health of the planet could be represented with the HRV score?
Potentially, yeah.
Wow, yeah.
Because, I mean, if your HRV is low, there's a lot of other things that are happening. High inflammation, high stress, more apt to maybe be violent, to act out, those kinds of things. But if you're more creative, you're more able to solve problems. And we need problem solvers rather than people complaining about the existing order. I mean, we literally need people who are able to get into flow state, able to kind of tap into some source, some creativity, and really think of big solutions to the problems we have today. It's not going to come from being stressed, this kind of lower level.
Feels like Earth's global health is, the planetary global health is further down. Right now.
Yeah, and you have to know these are people who went out and purchased the Elite HRV fingertip sensor.
Sure. So it's already
only people.
Exactly.
So we don't really have the global thing yet, but it's possible. I mean, most of these iPhones have the ability to detect your heartbeat with their camera.
Yeah,
so it's possible
their
that
facial recognition.
Facial recognition apps. There's a big ecosystem that can be coming.
Yeah.
And so this is another thing. I just want to touch on this cool factor, which is there's a lot of really impressive things that can happen for your brain if you stimulate your vagus nerve, either through breathing, through exercise. Cold showers work really well.
Yeah.
You can take a cold shower, take a cold plunge, cryotherapy, those kinds of things are really good for stimulating this to ventral vagal. But one thing that I found recently was an article showing that vagus nerve stimulation increases BDNF, which is basically a growth hormone for neurons. And this is a big indication in people who are suffering from depression, is they have a huge decrease in BDNF, brain-derived neurotrophic factor. So if you stimulate your vagus nerve, BDNF will go up and more neurons will start growing in your hippocampus, which is where short episodic memory resides. And neuroplasticity anywhere in your brain is pretty much a good thing. So if we go to the next slide, there's some actual pictures. So on the left is colored DCX cells, which are related to microtubules, actually. And on the right is just sham stimulation. So this just shows that if you do VNS stimulation, you can have really positive growth of important neurons in your hippocampus. And then if we go to the next one, we can see that, so this is actually the VNS, that's the sham, it's switched.
Okay.
But you see more BDNF cells, so actually a pretty big rise. And this is, I believe, just shortly after, and then after, I think this is after 3 weeks of stimulation every day.
Okay. Oh, every day.
Every day.
Okay.
Yeah.
Okay.
Yeah. So it's it's not just like neck down; it's also neck up.
Yeah.
So there's a lot of good stuff that happens in your head. As well. So
and this is transcranial.
This is actually with
this?
electrodes implanted in your neck.
Okay. Yeah. Implanted in.
Yeah.
So with that little.
But this is on rats.
This is on rats.
Yeah.
Okay.
Yeah.
Electrode in the neck on the vagus, that coil on the vagus.
Yeah,
nerve.
Exactly. Yeah.
Okay.
Yeah. In research, but there are developing technologies that can actually let you stimulate your vagus nerve without surgery. So things that are handheld devices that you put over your vagus nerve.
Yeah.
That are like electrical, or some with light, some with ultrasound.
Yeah.
So there's there's a lot of development in this direction.
And stimulate with light. And then what would be the result of the increase in BDNF?
So basically BDNF would make you more resilient, more able to respond appropriately to new situations. So more neuroplasticity means you're able to learn from your mistakes better.
Okay.
It's really, antidepressants basically grow BDNF in the brain. Makes you smarter.
Okay.
Gives you better memory. Yeah. So yeah.
And the last one is
this was the animated GIF that we never.
So this is just a filler slide I wanted to throw in, but it kind of points to kind of where I see this all going, which is that I think we're coming up to a future where we have an increase in machine learning, artificial intelligence, EEG, brain stimulation. There's so much going on that's in these different pathways that I'm really starting to see this desire to merge this stuff together. And so I have this kind of unique position to see where this is going, to have been in it for so long. And so essentially the future over the next probably 5 to 10 years will be developing a real-time brain stimulation system that is multi-channel. So it would be like different channels of ultrasound all over your brain instead of one big targeting thing. It's tiny little ultrasound things. Adjacent to EEG. So reading the brain and stimulating the brain. Putting it into a machine learning algorithm, seeing your brain in real time from the machine and stimulating it in real time. Almost like a self-driving car. So you think of like the Mobileye system.
That's pretty crazy.
In a Tesla, it's like an auto driving, essentially but powering the brain. So that's
reading through EEG and then having ML algo figure out how you want to stimulate to get you and yourself into a flow state or into wherever you want to go, and then the amount of control that we have at that point is like,
it's insane. So probably where it'll start is taking a recording of your brain in one 5-minute segment and then telling the machine to figure out how to make that happen again by driving it. So it's like just doing a recording of somebody driving down the freeway and taking in the data, training it, and then saying, okay, now we're taking off the training wheels and we want you to try and drive that brain activity to look like how it looked like before. So that's kind of the future. That's kind of the short-term future. But then long-term, 50 years from now, this will be all integrated in your head. But probably in about 10, 15 years, this will become, so we have 6 layers of the human cortex. And these are what makes us human, basically. The cortex is like our human part of our brain. This will become the 7th layer of the cortex. Just an extra cortical layer that's upgradable. Because you can't upgrade your cortex, because you can't expand your brain, you can't get into your skull. We can't do that yet. Maybe we can do stem cell injections to grow your cortex bigger or something, make it more dense. But this is upgradable. So you can put more NVIDIA graphics cards out here. And that all connects and powers the machine learning algorithm. And so these will actually co-develop with each other. So your brain will learn that it's actually being influenced externally. And so your brain will start to figure out how to do it.
You think that we're going to end up wearing the 7th layer at our organizations and in our homes, and that certain people will choose to not wear it and just be left behind, or what's the?
I think it'll be common in brainstorming sessions. So if you really need to put on your thinking cap, this will literally be the epitome of a thinking cap. So it'd probably be executive board meetings where they're like, okay, we really need to think this, because the rapid pace in which decisions need to be made.
Like no mind wandering, you have to super focused, super creative, super flow, super empathy. So this will be like Jeff Bezos will be like contracting us and be like, okay, I need the thinking cap. We'll have a mobile van that goes to his office, or maybe they'll have these in every executive suite at the top of every building, something like that. So it'll be like a thinking room, a 30-minute thinking room that you go, like at the top of the Salesforce tower, they'll have a neuroscience lab where executives take an elevator up, sit for 30 minutes, process immense amounts of data, and then go take a nap and spit out their answers after that. Something like that. That's probably where this is going. Ron?
This reminds me I need to change my name to 11101966PR2-5912.
I mean, we're already doing that if you think of it. Like our cell phones act as an external processing layer. So, this is just just an extension of that.
This reminds me too that some of the thoughts about the indigenous are that just like, little brother, be careful with the way that you play with the godlike technology, because the civilization could collapse from your thinking that you know everything and that you're gonna.
Did they say could or will? That's. Are you sure they said could?
Well, we're already at risk of who knows. I mean, who knows what's going to happen in the next 50 years? I mean, I think we just, like I said, I mean, I think the solutions will come from like incredible leaps in creativity and development, and I think we do kind of at this point need some help, because it's almost like there is an element of humans versus the machine in one way, but it's like we do need to develop with machines as well. We are going to need to kind of get their help. So this is kind of how I see, potentially, this is how it will help us, not be against us.
Interesting. So there could be the added layer of machine intelligence to make sure that the civilization doesn't collapse.
Correct.
Interesting. Yeah. Fair point. Yeah.
You might have like an oracle class that just kind of sits with these all the time. That, like, you know, the kind of the global, the elite thinking unit. Sure. People who are born. This is getting way out there. This is like way super sci-fi shit, and I don't really know. I'm just thinking on my feet.
It's like tomorrow in terms of cosmic time.
Yeah, it is. It's a blink of an eye in terms of when this could happen. But, you know, I think about it, like, I know people who just spend about 8 hours scrolling through Instagram, deciding if this is something worth liking or not. So there's computing power in the human collective consciousness that's being, I think, wasted. Like, does Instagram need to know that a celebrity looks good? Heart. Okay, this girl in a bikini looks good. Yeah. It's like we're using computing cycles right now. We're essentially
uselessly. Yeah.
Uselessly
with low utility. Yeah.
Yeah.
Okay, so wearing one of the neuromodulation caps, could rocket me into creative flow states rather than be manipulated or deceived by things that are distracting me.
Right.
Or I could build up my own repatterning mechanism. So here's the thing: is like, okay, so I think here's what we're getting at. Yeah. It's that we can take time to repattern our own behaviors towards nature and towards our own self-actualization, collective actualization. But is that actually going to come fast enough to avoid some of the civilizational collapse issues we have? Because we can augment ourselves with this to repattern those behaviors quicker to avoid the civilizational collapse and to connect faster to what provides us with life, our nature, as well as some of the creativity. Okay, all right. I want to hit mimetic warfare with you too on the way out, because I think you and I both are carry this mentality of like the age of the gene seems to be, in a sense, taking a back seat to the age of the meme. Like, you can disseminate memes and impact 8 billion people, but if you birth a child into the world, your time investment's in one child. So what are your thoughts on the mimetic warfare age?
Yeah, so it's a weird thing of how I actually learned about any of this stuff. It was just by total chance. I was learning how to run Facebook ads, and it was pretty much 2016, 2017, and I heard about how potentially powerful Facebook ads could be, and I wanted to kind of know if that was true or not. So I started looking into, like, what does it take to take a meme, some kind of a symbolism, some kind of a message, and rapidly propagate it through social media if you have, money behind it. And so I had to really research, like, what are memes, what is memetics, and so I got a really crash course for about 18 months, learning how to do Facebook ads and doing some better understanding of how people are influenced through social media. And it really does relate back to my work in neuromodulation, which is, we're using a technology to stimulate the brain. Instagram and Facebook are stimulating people's brains. It's like, if you can't make that connection, it is there. Yeah. So I'm always thinking about what are the implications of, this is a small technology that's going to be in the hands of a very few researchers over the next few years. But what if this gets mainstream? Like, what are the implications? And we already have an example, which is social media. It's machine learning driving a system where you have an input, you have an audience, you put it to their eyes, they give feedback, you collect data on that. The machine makes some adjustments, and then it tries another round of stimulation.
Yeah.
So it's stimulation of the global brain,
yeah.
through your phone, though.
Yeah.
So this is just the thing I think about, whether it's on an individual level in the brain or if it's on a massive scale. And so what I found was that, through social media, it did seem to, we talked about this earlier, which is that it did seem to be easier to create discord and disconnection with people through these ads. If you're trying to, it's a lot easier to do that than to create some kind of connection. It takes a lot more work to connect people than to just be, just throw out a bunch of garbage onto the internet.
It's a lot harder to make newsfeed nuanced multivariability within news feeds and empathy and love than it is to make things that bias people into tribes and fear response, endorphins versus like love and compassion and unity. Yeah. But then the parallax is also important because then you have actually like ideas that can like build on top of each other at times versus just this is kind of another one of the debates between what US is and China is kind of like moving forward with. I want also regarding influencing the global brain. I feel as though we can do it on a neuromodulation using neurotechnology basis, these thinking caps, this type of stuff. But when you explain it in terms of just like being influenced by even like a news feed or a video or these types of things, I think that deploys to 2 billion people like that, and I think that's much more relatable. I think also for people that like this is very important that we figure out how to what is the most optimal way to deploy these memetics through the news feeds in order for us to maximize our prosperity and not our disconnection. Yeah, that's a huge one.
Definitely. And it's the nature of the viral meme is it's things that it's really this whole sympathetic nervous chain is it's not a coincidence where I'm learning about how people are affected by something they see, how the people are viscerally affected by things they see on the internet. They feel it like as if it's a real threat to their being. And in some cases, on a global political level, there are threats, but some people can take a meme as a very real threat, like a saber-toothed tiger is coming out of your laptop.
Yeah, correct.
So it's a lot easier to get control over somebody's mind if you're using fear on these platforms.
Yeah.
So it's almost child's play to create
love and compassion memes. Yeah.
Those don't perform nearly as well as fear-based memes.
That's the thing is that we gotta kick out the fear. Because they perform better.
Right.
Because we need the other ones.
They'll never take me alive.
Ron, they've taken you so long ago.
Yeah.
They gotta. Okay, let's do a couple quick questions on the way out.
Okay.
What do you think happens before birth and after death?
Before birth and after death. I mean, besides the obvious answer, reproduction-wise. I don't know. The non-materialist answer would be something about if we're in a simulation or if we're in a hologram, which I think about that kind of stuff a little bit. If we're in some kind of a pre-simulation, then I think that there could be these ideas of archetypes of people that were kind of built into some original template that we're born from. Because I've had times where I've seen people and I've been like, you remind me so much of somebody else that I've met. This has happened multiple times.
Totally.
Because I've met so many people through this work, and I'm like, wow, it's like I'm talking to the same person.
Yeah.
You have the same interests. You have the same look. There's just some part of me that can't ignore that reality.
Yeah.
So there's something that
they got loaded from the same character archetype. Yeah.
Right. And there's generally so much variability in the species and in people that you don't normally detect it unless you're really careful to look for it.
And that you met a lot of people.
Yeah. Most people don't meet enough people to detect that, generally speaking. But yeah, if you do get out there enough, you go to enough conferences, you're out there enough, you start to notice these things. So I've kind of seen that, and that does make me wonder about what's going on before. What's the loading bay look like, kind of
The
thing.
loading bay?
Yeah, the loading bay of our consciousness before we get jettisoned out into the material world from the hologram simulation, whatever that is.
Yes.
And then in terms of when we die, I mean, that's such a loaded question. I mean, I don't know. Probably, it's really hard to say. You know, I've personally lost people to suicide. My sister, for instance, and I've thought about that for sure. Because I don't really know. I wish I knew. Part of me wants to know, but you know, I think that.
What was with her? What was it?
She was prescribed antidepressants for about 3 months, and she had attempted suicide before in her life, but never successfulully. But I think the antidepressants made her really decide to go for it, and she hung herself in Portland, Oregon in 2014. So it really sucked, and I remember I actually was trying to find answers and trying to figure out what happens, and I did find some research on that. You know, the brain still operates minutes, 15 minutes or longer, or hours after you die, and there's some idea that you're re-encoding your life experience back into the simulation. Like it's like a lived experience, and you like teach a lesson in some way. So that's my theory on what happens when we die. But I don't know if we're entirely coherent, but we get kind of like re-shuttled back into the hologram in some way. So we do kind of still have a lingering effect. Yeah.
This seems like it also kind of potentially launched you into wanting to understand like what was going on in her brain that made her decide to do
Definitely.
Which is why you're in this field now.
Yeah. And I work with people who are depressed a lot, so I really want to help. Yeah.
I'm surprised that you didn't mention that at the beginning. That was part of your your reason for endeavoring into where you're at now.
Yeah, it was a big. I mean, I actually did get into it before any of that happened.
Yeah.
But then that happened during the launch of my company, and so it just became more clear than ever that there's the time that's now to do this. I can't wait. I can't fail.
Yeah.
What's her name?
Carrie.
Carrie. Yeah.
Carrie.
Yeah. As long as we keep her alive in our heart and mention her name.
Yep.
Carrie Cooley.
Yeah. Carrie Cooley. Yeah. My older sister. She was 30 when it happened. I'm 30 now, so I'm the same age as my sister, which has been a interesting thing this year, in particular. But yeah, you know.
Was it just her and you as siblings?
Mm-hmm. Yeah. Her and me and my and her mom.
And mom.
My mom, mostly. Yeah. So it's never easy losing someone. Definitely opens up a lot of questions about what happened.
Yeah.
But
it also opens up our imagination to the possibilities of, you know, who we are. And you're asking these questions, Alan. What were you before birth? Where do you go when you die? And then we're talking about Carrie. So it does also open our imagination for wonderful possibilities beyond this body that holds us temporarily.
Yes.
Yeah.
Exactly, and just as fast as it comes, it can go. And so, you know, I think you got to make the most out of what you got.
Yeah.
Whatever you have, you got to make the most out of your time here.
Yeah.
Yeah.
That's right.
Absolutely.
That's right.
So do amazing stuff.
Yeah.
You know?
Do you think that we're in a simulation?
Yes and no. So I've thought about this. We are in a simulation for sure, and the simulation is I'm simulating you in my head right now. You're simulating me in your head. And the brain is a very low information holding cavity. There's so much more information in this room than that your brain is not detecting. Mm-hmm. So you'll find that, I feel like, you know, if you experience like psychedelics, you see way more of an inflow of information that you didn't realize was there. So yes, there's a simulation because there's a lack of information. So you have to simulate things. That's why optical illusions work so well. So there's that level of simulation. And then in terms of if we are in a silicone simulation or something, it's either that or we're in some kind of a hologram, like collected light photons that are densely packed inside of a black hole, meaning that our matter was already compacted into a black hole already, and we're just super dense photons floating around, influencing each other, thinking that we're conscious, imagining all this. That's the other option. Or we're just actually alive and this is all real and we're the first ones. And we will at some point simulate some people.
And then what do you think is the most beautiful thing in the world?
Most beautiful thing in the world? I don't know. I think like new generations of children, the people who aren't so cynical, that have a fresh perspective, people who have hope.
Yeah.
Yeah.
It's beautiful.
Yeah. Totally.
Sterling, thank you so much for coming.
Thanks so much,
on
man.
the
I
show.
appreciate it.
It's been such
Thank you.
Yeah, I really appreciate it.
Yeah. Totally.
Yeah.
Awesome, man.
Thank you.
Very cool.
Thank you. Thanks everyone for tuning in. We greatly appreciate it. We'd love to hear your thoughts in the comments below on the episode. Do check out the links as well to sterlingcooley.com, the website, as well as the Facebook group. Go and check that out. Go and join the group. And join the conversation worldwide with your friends, your family, coworkers, people online on social media about influencing the global brain through things as simple as memes, all the way to things like neuromodulation. So get talking about that more. Huge shout out to Ron Vagus for producing and directing. Thank you very much, Ronnie.
Thank you.
Yes, thank you. And also support the artists, the entrepreneurs, the organizations around the world that you believe in. Support Simulation. Our links are below. Help us grow as well. And go and build the future, everyone. Manifest your dreams into the world. Thank you so much for tuning in, and we will see you soon. Peace.